Imagine a train, not a sleek, high-speed passenger rail gliding quietly through a major city. I am talking about a massive, brutalist freight train, 10,000 tons of raw steel, stacked shipping containers, and heavy industrial weight. For over a century, moving a machine like that has required one of two things. Either massive diesel engines burning thousands of gallons of toxic fuel, or millions of dollars worth of highly explosive lithium batteries. But right now, deep inside China, a completely different kind of train is rolling down the tracks. It is not burning diesel. It is not running on rare, expensive lithium or cobalt. It is running entirely on salt and water. You heard that correctly. A Chinese rail company has successfully built and deployed a heavy freight locomotive powered entirely by a saltwater plasma battery. This is not a concept rendering sitting on a computer screen in a university lab. This is not a prototype waiting for funding. It is a physical, functioning train operating on real tracks today. To understand why this is sending shockwaves through the global engineering community, you have to understand what it actually means. For the last 10 years, the smartest minds in Silicon Valley and Europe have been locked in a brutal race to build batteries big enough to power heavy industry. And the entire Western world placed its bet on lithium. We dug the mines. We built the gigafactories. We fought geopolitical wars over the supply chains. We accepted that lithium was the only material on Earth capable of holding enough energy to replace diesel. Then, a team of engineers in China looked at the most abundant, dirt-cheap resource on the planet, ocean water, applied a brilliant breakthrough in plasma technology, and quietly made the entire American lithium strategy look dangerously outdated. If you can move 10,000 tons of freight with salt and water, you do not just change the rail industry, you change the entire global supply chain. You change the final cost of every single product sitting on American shelves, and you fundamentally rewrite the rules of global power forever. We love the electric vehicle revolution in America. Companies like Tesla and Ford have proven that lithium-ion batteries are fantastic for taking your kids to soccer practice or commuting from the suburbs to the office. But here is the brutal, unspoken truth about lithium batteries. A passenger car is essentially a toy compared to heavy industrial freight. When you try to take the battery from a Tesla and scale it up to power a massive locomotive, the math completely breaks down. First, there is the weight problem. Lithium batteries are incredibly heavy. To move 10,000 tons of steel across the country, you need a battery so massively heavy that the train ends up burning most of its energy just to haul its own battery. That is financially useless. Then, you hit the supply chain nightmare. To build these massive lithium batteries, you need cobalt, nickel, and refined lithium. These are rare, expensive materials. Getting them out of the ground requires massive open-pit mines, intense environmental destruction, and supply chains stretching through hostile foreign territories. The United States is currently spending billions trying to secure these materials, effectively locking itself into a fragile, highly vulnerable global trap just to keep its supply lines running. But the most terrifying problem is physics. It is a little thing engineers call thermal runaway. When a lithium battery is put under extreme, crushing industrial stress, like hauling a mile-long freight train up a mountain, it gets incredibly hot. If one cell fails, it triggers a catastrophic chain reaction. The battery erupts in a chemical fire that burns at thousands of degrees. You cannot just spray water on it. It creates its own oxygen. Imagine a chemical explosion on a freight train rolling through a major American city. The United States and Europe are trying to force this volatile, expensive, heavy chemistry to do a job it was simply never designed to do. We are betting our entire logistics future on a material that is too dangerous and too expensive for heavy freight. China recognized this trap a decade ago. They knew whoever solved the freight problem without using lithium would own the future of global trade. And that is exactly why they turned away from rare earth metals and started looking at the ocean. They realized that true dominance does not come from fighting over a rare metal. It comes from taking the most common resource on Earth and engineering it to do the absolutely impossible. For decades, scientists knew that sodium, the exact same stuff sitting in your kitchen shaker and filling the world's oceans, could theoretically hold an electrical charge. It is called a sodium-ion battery, or a saltwater battery. The concept itself is not new, but historically, there was a massive, frustrating problem. While salt is completely free and available everywhere, its atoms are much larger and clunkier than lithium. When you try to move that chemical energy around, it is sluggish. For years, saltwater batteries were incredibly weak. They were fine for powering a digital wall clock, but completely useless for anything that required serious muscle. That is where this Chinese engineering team introduced a total wildcard into the equation: plasma technology. They did not just try to build a bigger salt battery. They fundamentally changed how the salt behaves at a microscopic level. By using a highly advanced plasma treatment during the manufacturing process, they bombarded the internal structure of the battery's carbon electrodes. Think of it like taking a dense, blocked-up sponge and using a microscopic laser to blast perfectly smooth, high-speed transit tunnels straight through it. This plasma treatment reorganized the very atomic structure of the materials. Suddenly, those big, clunky sodium ions had a superhighway to travel on. They could move in and out of the battery cells at blinding speeds. This completely unlocked the energy density of the salt. The plasma treatment allowed the saltwater battery to store a massive amount of electrical power and, crucially, discharge it instantly with brutal force. But here is the absolute genius of the entire system, the exact detail that makes traditional lithium look like a ticking time bomb. Because the core chemistry relies on an aqueous solution, literally water and salt, the battery is physically, chemically incapable of catching fire. There is absolutely zero risk of thermal runaway. You could puncture this battery with a solid steel spike. You could crush it under the iron wheels of a train. You could heat it to extreme industrial temperatures. It simply will not explode. It cannot burn. The fundamental physics of the water-based chemistry actively cool the system down from the inside out. They took the cheapest, most widely available resource on the planet, hit it with a controlled plasma beam, and created an industrial power source that is perfectly safe, insanely cheap, and incredibly powerful. It is an elegant, unapologetic flex of modern material science. But having a safe, high-capacity battery sitting on a laboratory workbench is just step one. Storing power is one thing. Taking that stored saltwater energy and translating it into enough raw mechanical torque to drag 10,000 tons of dead weight down a steel track? That is a completely different physics problem. Let us put 10,000 tons into perspective. That is not just heavy, that is a geographical event. To move that much dead weight from a dead stop, you do not just need energy, you need an apocalyptic amount of raw, instant torque. If you have ever stood next to a traditional diesel-electric locomotive when it starts moving, you know exactly what I mean. The ground physically shakes. Massive diesel engines scream as they burn through gallons of fuel just to inch the train forward. The physics required to break the static friction of a mile-long steel snake are absolutely terrifying. When engineers first heard about this saltwater plasma battery, the skepticism was deafening. Sure, it is safe. Sure, it is cheap. But can a battery made fundamentally from ocean water actually punch with the brutal, sustained violence needed to replace a heavy diesel engine? The answer, verified on the tracks in China, is yes. Because of that plasma-altered internal structure we just talked about, this battery does not just trickle power out, it dumps it. When the train's computer demands acceleration, the saltwater battery floods the electric traction motors with a massive surge of current. It generates instant, continuous torque directly to the steel wheels. No waiting for turbochargers to spool up. No waiting for a diesel generator to hit the right RPM. Just pure, silent, unstoppable electric muscle, delivered immediately on demand. And because the battery is chemically immune to catching fire or overheating, the train can pull maximum power for extended periods. It can drag thousands of tons of cargo up steep mountain grades without the system melting down. In fact, electric motors are fundamentally better at this job than diesel engines, provided the battery feeding them can actually survive the stress. This saltwater plasma system survives it effortlessly. It is outperforming traditional locomotives on efficiency, maintenance costs, and reliability. There are no pistons to rebuild, no oil to change, no massive diesel fuel tanks to refill at exorbitant daily costs. You just recharge the saltwater cells, and the train keeps rolling. China has successfully married the raw, brute force needed for heavy industry with the safest, cheapest battery chemistry on the planet. They just solved the ultimate physics problem of the 21st century. But this engineering marvel is not just a cool story about trains in China. It is a direct, calculated threat to the entire American transportation empire. Every single thing you buy in America, the food in your local grocery store, the lumber used to build your house, the spare parts sitting in your car, moves on a massive invisible conveyor belt of heavy rail and long-haul trucking. Companies like Union Pacific and BNSF Railway are the actual blood vessels of the American economy. If it costs more to move that freight, everything gets significantly more expensive, inflation spikes, and the American consumer always pays the final price. Right now, Silicon Valley and Detroit are aggressively trying to electrify that massive conveyor belt. But they are making an incredibly dangerous, multi-billion-dollar bet on the exact wrong technology. Look at the highly publicized Tesla Semi, or the heavy electric locomotives currently being tested across the United States. They are all desperately trying to force expensive, heavy, fire-prone lithium-ion batteries into heavy industrial transport. It is a brute force approach that costs an absolute fortune. An American transport company has to pay an enormous premium for the rare raw materials, the advanced liquid cooling systems required to prevent thermal runaway, and the heavy insurance policies just to put these massive machines on the highway or the tracks. Now, look across the ocean at the Chinese cost sheet. By running heavy freight trains on saltwater plasma batteries, their domestic logistics costs are plummeting. They are not paying a massive premium for cobalt mined overseas. They are not buying multi-million-dollar safety systems to prevent catastrophic chemical fires. They are literally pulling their core battery components out of the ocean. The math here is completely brutal. If it costs a Chinese manufacturing hub a fraction of the price to move 10,000 tons of steel or electronics compared to an American hub, American manufacturing simply cannot compete on the global stage. This is the exact nightmare scenario keeping logistics executives in Detroit and Silicon Valley awake at night. You cannot out-innovate a competitor whose fundamental energy source is practically free. If the United States logistics network remains chained to expensive, fragile lithium technology while China moves its massive industrial base over to dirt-cheap saltwater, the baseline cost of American goods will naturally become uncompetitive. It is not just about who builds the coolest, most futuristic train. It is about who builds the cheaper, safer system to power the entire backbone of their economy. The United States is currently spending immense political and financial capital to dominate the electric future. But the real threat to American industrial dominance is not just about the daily cost of moving freight. It is about the fundamental raw materials that make that movement possible in the first place. For the past decade, Washington has been playing a massive, high-stakes geopolitical game of chess. The ultimate prize is no longer crude oil. It is lithium, cobalt, and rare earth metals. The United States government, alongside major American corporations, is currently spending billions of dollars to secure mining rights in remote corners of South America, Africa, and Australia. They are doing this because the entire American economic strategy for the next 50 years assumes that whoever controls the world's lithium supply controls the future of global transportation. It is a modern-day gold rush, and it is incredibly stressful, deeply expensive, and highly fragile. But while America has been digging deep into the earth, fighting fiercely for every single ounce of rare battery metals, China just completely bypassed the entire battlefield. By successfully scaling saltwater plasma batteries to power heavy industry, they have effectively opted out of the global resource war. Think about the terrifying strategic advantage of that move. Salt is not a rare commodity. It is not hidden deep inside a conflict zone. It covers over 70% of the Earth's surface. You do not need to negotiate complex international treaties or deploy the military to secure it. You just pull it straight from the ocean. By shifting heavy transport to salt, China has perfectly insulated its most critical domestic supply chains from any potential global shortage or American trade restriction. If a sudden geopolitical crisis cuts off access to lithium tomorrow, the American heavy electric truck fleet grinds to an absolute halt. Meanwhile, the Chinese heavy rail network, powered by essentially endless, dirt-cheap saltwater, just keeps rolling forward. This makes the current United States strategy of stockpiling rare earth minerals look entirely obsolete for heavy industrial applications. America is fighting a costly war for expensive dirt, while its biggest competitor just figured out how to run their supply chains on seawater. It is a brilliant, unsettling shift in global power dynamics. The rules of the geopolitical game did not just change, the entire game was completely rewritten while most of the Western world was looking the other way. But this massive disruption does not stop at the edge of the railroad tracks. Because if you can build a cheap, completely fireproof battery powerful enough to haul 10,000 tons of steel across a continent, where do you put that technology next? The moment you prove a saltwater plasma battery can move a heavy freight train, you immediately unlock the solution to the biggest, most expensive problem facing global energy today: the renewable energy grid. We all know the fundamental flaw with solar and wind power. The sun does not always shine, and the wind does not always blow. To actually make renewable energy work on a massive national scale, you need to store that power somewhere massive for when the grid goes dark. Currently, the United States is trying to solve this by building massive, football field-sized installations of lithium-ion batteries. Companies like Tesla are selling massive megapacks for grid storage. But again, we hit the exact same brutal problems. Building massive lithium grid batteries is astronomically expensive. And more terrifyingly, packing that many volatile lithium cells tightly together creates a massive fire hazard. A single lithium grid fire can burn for days, releasing highly toxic chemical smoke into nearby communities. It is a deeply flawed, incredibly risky way to power a nation. Now, apply the Chinese saltwater breakthrough to that exact same problem. You can stack these saltwater plasma batteries in massive warehouses, wire them directly into the national power grid, and store enough energy to power entire cities. And because the core chemistry is literally water and salt, they can never, under any circumstances, catch fire. You completely eliminate the risk of a catastrophic grid explosion. You completely eliminate the need for massive, expensive liquid cooling systems. And the cost? It is a tiny fraction of the price of lithium. This means you can build energy storage facilities 10 times larger than anything currently operating in the United States, for significantly less money. China is already actively deploying these exact systems to stabilize their own power grid. But they are not stopping there. They are currently scaling this technology for commercial cargo shipping. Imagine massive cargo ships, completely replacing their toxic, heavy bunker fuel engines with massive, completely safe saltwater batteries. The compounding scale of this disruption is staggering. They are systematically moving every heavy, high-energy industry away from expensive, rare materials and toward the cheapest, safest chemistry on the planet. The technology is real, it is scaling rapidly, and it is actively redefining how the entire world stores and uses power. It brings us to a massive, unavoidable conclusion about the future of the global economy, and the very narrow window America has left to respond. We are standing at the edge of a massive global transition. For the last century, global power was dictated by who controlled the oil. For the last 10 years, we assumed the next century would be dictated by who controlled the lithium. But what this Chinese freight train proves is that the future of heavy industry does not belong to the countries fighting over rare, expensive dirt. It belongs to the countries that can engineer the abundant, free resources right in front of them. The United States is currently pouring hundreds of billions of dollars into lithium gigafactories, desperate to secure a supply chain that is already looking deeply fragile. Detroit and Silicon Valley are building incredible passenger cars, but they are trying to force that exact same expensive technology onto the brutal reality of heavy freight. Meanwhile, China has successfully decoupled its massive logistics network from that entire expensive race. They took the most abundant resource on the planet, hit it with plasma technology, and built a system that is cheaper, safer, and infinitely scalable. If the American logistics empire does not pivot, the math becomes completely unavoidable. A country that moves its steel, its food, and its consumer products using practically free ocean water will always outcompete a country paying a massive premium for volatile, rare earth metals. The window for the United States to adapt, to look beyond the lithium trap and invest heavily in next-generation alternative chemistry, is closing incredibly fast. It is no longer just a cool technology race. It is a fundamental battle for the basic cost of survival in the modern global economy. The rules of the game have officially changed. The era of the saltwater plasma battery is here, and it is already rolling down the tracks, carrying 10,000 tons of heavy freight right past the legacy systems of the past. If this video changed how you look at the future of global power and technology, hit that like button right now and subscribe. Turn on notifications, because we are constantly tracking the massive industrial shifts that most people never see coming until it is already too late. Now, I want to hear from you. Do you think the United States can pivot away from lithium in time to protect its heavy industry, or has China already permanently won the logistics war? Drop your honest answer in the comments below. I read every single